Hi, this is Mr. Sampson with a short discussion on mineral properties and minerals. What is a mineral? Well, let's take a look at what minerals are not. Are they or aren't they? To be classified as a mineral, a substance must satisfy 5 requirements. They have to be naturally occurring, can form by inorganic processes, solid, they must have a crystal structure, and they must have a definite chemical composition that is just their own. Naturally occurring. All minerals are substances that are formed by natural processes. Quartz is formed naturally as magma, which is molten rock underneath the surface of the earth, cools. Coal forms naturally as plant remains are squeezed tightly together. So, can they form? If you take a look at this, they are both naturally occurring, both coal and quartz. Let's move on. Can be formed by inorganic processes. Organic is anything that comes from living matter. Inorganic is derived from non-living matter, rocks, minerals. So let's take a look at where we're going with this now. Can be formed by inorganic processes. Well, quartz definitely, and but of course coal is not. So we're going to have a check on inorganic, and let's move on. A mineral is always a solid. A solid has a definite shape and has volume. So if we take a look at solid here, definitely quartz is a solid, and of course coal takes up space too, so it's a solid as well. A mineral has a crystal structure. Now, here's where we find some differences. The quartz crystal definitely has a crystal structure, but now a coal does not. So we'll put a 0 right there. A definite chemical composition. If you take a look at this chemical composition for quartz, you definitely have a repeating composition, and that's why you grow these great looking crystals that all have similar shapes, but with quartz, for example. An indefinite chemical composition of coal. Here are 2 different actual compositions for coal. You can see there's some differences in the 2. So there is not a definite composition. So we'll go back to chemical. Quartz has a crystal structure, but let's face it, the chemical composition for coal is a 0 again. So we are going to alleviate coal as a mineral. Our conclusion: quartz is a mineral, and coal is a naturally occurring solid substance, but it is not a mineral. The properties of minerals are used to identify them. They are color, streak, luster, hardness, density, crystal structure, and fracture and or cleavage. There is a difference between the two. Mineral properties, let's start with colors. The actual color of the mineral. Many minerals have the same color. Mineral properties. Streak is our focus right here in this upper right hand corner. Streak of a mineral is the color of its powder when it's scratched on a white porcelain piece of tile. Now you really want to watch the mineral properties, in particular when you're testing hematite. Hematite has a silverish metallic gray color, but its streak is a definite reddish brown. Mineral properties, luster. Luster has to do with how light is reflected off the surface of the mineral. So now, one of the key mistakes that kids run into is the fact that we start to mix it up with color. Now, if you look, metallic tends to have a sparkly silverness to the color. It could be red metallic, it could be blue metallic, but it still has that silvery sparkle. Gypsum is a fine one for that pearly sort of luster. It sparkles and sometimes you get a bit of a rainbow color. Waxy would be something that we would consider talc to be, and of course we will use the word vitreous, and vitreous means glass-like, and mineral crystal is definitely glass-like. Obsidian isn't a mineral, but it has that definite vitreous luster. Hardness. Hardness is measured on the Mohs hardness scale. We've been learning that this week. You'll start out with, and when Mohs designed the hardness scale, he used talc as his number one. He also used another key mineral, which is quartz, as his number 7. You can barely see that. And another key he went with is the hardest, which is the diamond right there at a 10. And that is what you're working with. Now you want to be really careful when you're working with Mohs hardness, that as soon as it scratches something, you want to stop and not move on. Density. Density has to do with the amount of stuff in a given volume. Each mineral has a characteristic density or mass per unit volume, and that can be found by using this formula. We'll do a lab on that using water displacement to figure out the volume of certain minerals. But it can be very, 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 very accurate. Mineral density is a good system, although it does take a little longer to use. Mineral properties, crystal structures help to identify minerals. The unique chemical composition of a mineral is continually repeated in the mineral, creating its mineral crystal. There are about 6 to 9 definite crystal shapes. You'll notice that over here with the pyrite is a cube, and if you recall, our halite or common salt was also that cube structure as well. Fracture and cleavage, we won't be doing a lot of this. just for the mere fact that it uses up our minerals. But in particular, if you take a look at these calcite crystals, if you start to learn these crystals just by the sort of collapsed box shape, you will begin to know calcite on a pretty quick basis. So watch for that collapsed box. And also cleavage again on mica. It will often peel off in sheets, and that's a definite giveaway from mica. And all kids know the mineral mica. The properties of minerals are used to identify them. Well, who cares? Why should I have to learn about this stuff? Jeez, you know, how many times have you said that as a kid? Well, what if you were walking down Last Chance Gulch in Helena, Montana, and you came upon this fine, sort of shiny, luster, goldish colored mineral, and it had let's say a Mohs hardness of maybe a 4 or 5. You could actually sink your teeth into it. Well, I'm sure that you're going to care, and when you take this down to the bank and you cash in your $600-700, versus if you found this, which is quite common, especially in this area, this little chunk, and you walked into the bank and you said, hey, I want my money, and they told you, well, that is iron pyrite and is worth not very much. What if? You bet. Sink your teeth into it. It has a Mohs hardness of about 5. If you use any of these items, minerals are important to you. These are just a few of the thousands of items. I believe that most of you live in a house, and so it's important to you. I believe a lot of you get around in a car, and let's face it, we all love our technology, and I love my bicycle. And if you've got little metal eyelets on your tennis shoes, you love minerals, and every baby loves mineral talc, which is baby powder. Mineral properties are found throughout our planet, and if you take a look right here in this region, many of them come from what is, you will be learning, they are igneous intrusions. That is hard magma that intrudes upwards into sedimentary rock and hardens, and oftentimes this is where a lot of minerals are found. The Berkeley Pit in Butte, Montana was one massive bunch of veins of igneous intrusions, and they wound up just digging out the whole thing. Again, minerals are found throughout the world, and if you take a look at our fantastic United States, we get a whole lot right from our lower 48, and this is a part of our great wealth. And of course, these regions here are home to some aluminum, and this region here is where diamonds come from. And you'll notice that some of the wealthier countries, like the United States, like South America, like China and Australia, tend to have a lot of minerals. Thank you.